Hi and welcome to Quick Math. In this segment, we shall discuss decimals, specifically the math operation for decimals. And do stay with the tutorial questions as they're designed to stretch your understanding of the math operations for decimals. Let me start with how I would describe decimals. I kind of like to think of decimals being synonymous to a fraction, where each digit present to the right of a decimal point can be thought as having a measure with a denominator in the powers of 10. For example, 0.2 is equal to 2 over 10. 0.03 is equal to 3 over 100. 0.005 is equal to 5 over 1000, and so on. Before getting into the nitty-gritty of decimals, I would like to speak about decimals in relation to the powers of 10. We should be able to decipher from the earlier definition that when a decimal is multiplied by 10, the outcome is obtained by moving the decimal point one place to the right. In general terms, when a decimal is multiplied by 10 to the power n, the decimal point will move by n places to the right. In the first example, when a decimal is multiplied by 10, the outcome is obtained by moving the decimal point from the right of the digit 0 by one place to the right, hence newly at the right of the digit 2. In the second example, when a decimal is multiplied by 1000, the outcome is obtained with the decimal point moving 3 places to the right. The inverse is to have a decimal point divided by 10. The outcome is obtained by moving the decimal point one place to the left. In general terms, when a decimal number is divided by 10 to the power of n, the decimal point will move by n places to its left. Looking at the second example where a decimal number is divided by 1000, the outcome is obtained by moving the decimal point 3 places to its left. We've now come to our first tutorial question. So do press the pause button as required. How does one express 28.92% in decimal form? Percent is like dividing a number by 100. Hence, the correct answer is 0.2892. Tutorial question 2. Do press the pause button as required. What is the outcome of 2.579 divided by 1 over 1000? Here, when a number is divided by 1 over 1000, it's like having the number being multiplied by 1000. Hence, the answer is 2579. Now, if you're unsure about how to get to the answers for tutorial questions 1 and or 2, you can learn more about fractions and percentages by referring to the video on Quick Math about prime factors, HCF, LCM, and fractions. This slide discusses how decimals are added. When adding decimals, it behaves in the same way as adding integers, once the decimal numbers are lined up. In the example of 0.235 plus 0.78, which equates to 1.015, the method is as below. In the same manner, when subtracting decimals, the decimals must line up. In example of 0.772 minus 0.58, which equates to 0.192, the method is as below. Here we'll talk about multiplication of decimals. In method, decimal numbers are being multiplied as integers, and the total number of decimal numbers from the numbers being multiplied will determine where the decimal point is positioned at the outcome. For example, 1.2 times 1.1 is 1.32. In the example, the outcome has two decimal numbers, as each of the numbers being multiplied carries one decimal number each. Here's another example where the outcome has 5 decimal numbers, as the first number has 2 decimal numbers and the second number has 3 decimal numbers. It is therefore quite normal for 0.2 times 0.2 times 0.2 to be as small as 0.008. Now for the example in the previous page, if one were to translate it to fractions, it shall take the form 101 over 100 multiplied by 1234 over 1000. And it should get to 124634 divided by 100,000. In this form, it should be more obvious why the numbers are being multiplied as integers and the decimal point of the outcome is determined by the numbers being multiplied. Finally, when dividing decimals, it is very much simpler to appropriately convert the secondary number to an integer before attempting to perform the division. For example, 1.44 divided by 1.2, which could be expressed as a fraction 1.44 over 1.2, you can start by converting the denominator or the secondary number to integer. Then perform division like what it is done for integers. Okay, time for tutorial question 3. Do press the pause button as required. What is the equivalent of 1.23 plus 1.23 times 1.23? You should have arrived at the answer 2.7429. If you haven't, it's likely that you have not applied BODMAS. Tutorial question 4. Do press the pause button as required. What is the equivalent of the inscription on question 4? You should have arrived at the answer 3.076 applying BODMAS. If you still have not got it, here's how it's done. Start by executing O of BODMAS, whereby 1.2 to the power of 2 becomes 1.44. Next, you multiply 1.44 by 2.9, getting 4.176. To get at the answer, it's a simple addition and subtraction of the numbers. Tutorial question 5. So do press the pause button as required. The question reads as, simplify 0.001356 to 3 significant numbers. If you pick 0.001, this is the representation of 3 decimal points and is not related to the question. If you pick 0.00135, this is a 3 significant number, but yet applying the rounding rule. The correct answer is 0.00136. Tutorial question 6. Do press the pause button now as required. What equates to the cube root of 0.343? Now recognizing that 343 is the cube of 7, the answer is 0.7. Tutorial question 7. Do press the pause button now as required. What equates to 0.729 to the power of 2 over 3? Again, recognizing that 729 is the cube of 9, which will arrive at the answer 0.81. If you're one of those people who like things to be on a single page, here's a table of all the math operations for decimals. In summary, when it comes to addition and subtraction, align the decimal point, add or subtract as you would do for integers. As for multiplication, multiply as if the numbers are integers. Place the decimal point per how many decimal numbers are presented within the numbers being multiplied. For division, convert the numbers into a fraction Scale the fraction until the denominator becomes an integer and divide as you would do for integers. When performing orders or powers, much like multiplication, multiply the number as if it is an integer and position its decimal point as in the multiplication process. I've also taken the liberty to pair up the summary table that you will find on fractions under a segment of quick math about prime factors, HCF, LCM, and fractions. Use this as your quick guide whenever you wish to recap on math operations for both decimals and fractions. That's all you need to know on decimals, and have a good day. Bye for now.